Hello, I'm Mrs. J, and welcome to my math class. Today we're going to work more with limits. When you're finding the limit as x approaches a number and you're given a function, something like that. The first thing you want to do, just plug it in and see what you get an answer. If you get an answer, then you're done. So if we plugged in 5 squared plus 2 times 5 over 3 plus 5, 25 and 10, 35 over 8. And there's your answer. So if you plug it in and get an answer, you're done. I think the limit as x approaches 2 of 1 over x plus 3 over x all over x. Still plug in a number and see what happens. If we plug it in, we have 1/2 plus 3 over 2 all over 2. 1/2 plus 3/2 is 4/2, which is just 2 over 2 is 1. So the limit as x approaches 2 is 1. Okay, how about this one? Plug it in. 5 squared minus 25 over 5 plus 5. 25 minus 25 is 0 over 10, and 0 divided by 10 is 0. What if the bottom was a minus? So that we had this. Okay, when we have this and we plug it in, (25 minus 25 is 0, 5 minus 5 is 0. This is indeterminate. We need to go back and factor. Somehow it has to simplify, and in this case we can factor the top. So the x minus 5's cancel, and we have the limit as x approaches 5, and 5 plus 5 is 25. So you can still find the limit. So if you get 0 over 0, you need to simplify. Now there's some on the homework. So if we look at this one, x squared plus 5x minus 36 all over x squared minus 16, and the limit as x approaches 4. Okay, so I wrote it down here. That's the limit as x approaches 4. So if we first thing, plug in 4 and see what happens. So 4 squared is 16 and 20 is 36. Minus 36 is 0 over 4 squared is 16 minus 16, 0. That means that somehow there's a common factor and we need to go back and reduce it. So we want the limit as x approaches 4, and it'll factor x. X minus 4 and x plus 9. And on the bottom, x minus 4 and x plus 4. The x minus 4's cancel. So then we go back and plug it in again. We have 4 plus 9 over 4 plus 4, which is 13/8. So when you can simplify, you need to go back and simplify. Another one in the homework is, I think I can do this one here. The limit as h approaches 0. And if we plug in 0 here, we're going to have 2 over 3 plus 0 minus 2 over 3 all over 0. This is going to be 2/3 minus 2/3. 0 over 0. So that means we need to simplify it. In order to simplify, you want to multiply by your common denominators, and this would be a 1. So we're going to multiply by 3 times 3 plus h, and then the 1, 3 times 1 is still 3. So you're going to take all of these and multiply by 3 times, let me make it bigger. And the denominator, you don't want to multiply the denominator out because you want that h that was originally there to cancel. So if we multiply this, this 3 plus h cancels with this one and leaves 2 times 3, which is 6. This 3 cancels with this one, and then I have a negative 2 that I'm going to distribute. Negative 2 times 3 is a negative 6. Negative 2 times h is a negative 2h all over h times 3 times 3 plus h. The 6's cancel. And I left the bottom the same. And then the h's cancel and leave negative 2 over 3 times 3 plus h. Then we'll bring our limit back and plug in 0 because it's the limit as h approaches 0. 3 and 3 is 9, so negative 2/9. The cost in dollars for manufacturing a particular DVD is 5x plus 16,000, where x is the number of DVDs produced, and it's cost in dollars. Recall from previous chapters, the average cost of a DVD is this, and what that means is to find the average cost, you just take your cost function and divide by x. Or if you have a fraction, it's easier to multiply by 1 over x. But either way, now in this case, since it's linear, I would just divide by x. So the average cost function is just 5x plus 16,000 over x. Now when you're taking limits to infinity, when you're doing limits of infinity, you look at the degree of the top and bottom, and the degree of the top of this function is 1. Because it's your largest exponent, and the degree of the bottom is 1. When the degrees are the same, it approaches these two, the two largest degree terms. So 5x over x would be 5. So the limit as x approaches infinity of the average cost function is 5. What that means is as x becomes large, which is the number of DVD sales. So as the number of DVD sales become very large, the average cost is $5 each. So the average cost approaches $5 for each DVD as the number of DVDs becomes large, because x is approaching infinity. So it's giving you your cost per DVD rather than the total cost. When you're finding limits to infinity, I don't know if there's more or not. There's 3 cases. When the degree, like this one, on the top and bottom is the same, here the degree on the top is 2 and the degree on the bottom is 2 because of the exponent. When that happens, it's going to approach these two. When you're talking about billions squared, 6 times a billion is small compared to a billion squared. And so it will approach these two as your number's getting huge. And this is the case for positive or negative infinity. So then if you put them on top of each other, the two variables will cancel because they're in the same exponent. And it'll give you 2/3. So if we have this one, again, the degree on the top and bottom is 2. So you take those largest 2 terms and reduce them. The x squareds will cancel, 3/6, 1/2. So that's the one case, degree on top equals degree on bottom. If it does, reduce the 2 largest degreed terms, and that's your answer. Another one is the degree on the bottom is larger. If the degree on the bottom is larger, limit's 0. So if we have the limit as x approaches positive or negative infinity of x squared plus 2x minus 5 over x cubed, the degree on the top is 2, the degree on the bottom is 3, bottom's larger, equals 0. Because a number divided by a really large number, so if you took 1 divided by 100, 1 divided by 1,000, 1 divided by a billion, the larger you get, the closer you get to 0. So the limit is 0. If the degree on the top is larger, the limit doesn't exist. It approaches positive infinity or negative infinity. So if we had this, the degree on the top is larger, so the limit does not exist. And then since this is positive infinity, if you stick a positive value in the 2 largest degreed terms, positive 1, we'd get 5/1, which is 5. So it's positive infinity. So if it's positive infinity, plug in a positive 1. If it were negative infinity, take the two largest ones and plug in a -1. So the limit does not exist, but since we plug in a -1, we get a -5. It approaches negative infinity. So as this gets really large, it's going to approach a negative large number. But you can just test, as long as you just use the two leading terms, you can test it with -1 for negative infinity and +1 for positive infinity. Okay, this is similar to one we did, but this part is asking where it's discontinuous at. Anytime you have to lift up a point on your pencil when you're tracing it, that's where it's discontinuous, and you use the x value. So if I trace this, I'm going to lift my pencil here at 2. So it's discontinuous at 2. So we want to find the limit as x approaches 2 from the left, limit as x approaches 2 from the right, and f of 2. So it's discontinuous at 2 because it's broken. If we look at the limit as x approaches 2 from the left, we're on this side, and we're approaching 1, 2, 3, 4. So this going across is at 4. From the right, you're on this side, and our line's up here at 10, 9, 8, at 8. Oops. I think there's one more part, yeah. We also want the limit as x approaches 2. Since these two are not equal, this one does not exist. And lastly, f of 2. F of 2 is a colored in point. Where x is 2, the shaded point is here at 8. So this looks for a shaded point. This looks at just these two. If the limit as x approaches a from the right equals the limit, let me put equals out. So if the limit as x approaches a and the limit of x approaches a from the right and left, if they are both equal, and we'll say they equal L, then limit as x approaches a also equals that value. If the limit as x approaches a from the right does not equal the limit as x approaches a from the left, then the limit as x approaches a does not exist. Okay, this one we're graphing. And it says when x, well, we're picking which graph. If x is less than 1, our value is always -4. So if we look here, -1 is here. It's always -4, so that one works. Looks like they all work. -4, yeah, they all work. So that doesn't help us because that's only starting here and over. But they're all right there. This one is saying 7 when x is greater than 4. Greater than 4. So it should have started here. Wait, greater than 4. Actually, it should have had an open circle because it wasn't including it. This one's coming down, so I don't think that's right. Could be any one of these. So let's try this one. X plus 3 from 1 to 4. Find f of 1 and f of 4 and then graph them. Because it's a straight line, you can find the two endpoints. 1 plus 3 is 4. 4 plus 4 is 8. So from... Sometimes these are easy just to graph yourself. So I said this one here. Now if we look here at 1, it's at 4. And it's including it. This one is not including, so this would be an open circle. And then the other endpoint is at 8. Darn it. It should be a 7 because it was x plus 3. So it goes from 4 to 7. Four to 7, 4 to 7. But it should be colored in. And then it's saying everything greater than 4 is at 7. Well, since this is already colored in, we would have an open circle here, but this one colors it in. And it looks like this. And this should be colored in. And this should be an open circle. It's this one. So it's easier to try and just graph it yourself and then see which one matches, rather than trying to look at the graph. But once you do have it graphed, select the correct choice. The function is discontinuous. The function is continuous. Well, to tell if it's continuous, can you draw a line through the whole thing? Well, we said it was this one. If we draw a line, we're jumping here. That's the only spot. So it's discontinuous at 1. Find the limit or limits. Okay. Limit as x approaches. We said it was discontinuous at 1 from the left and from the right. So from the right, we're on this side, the graph's here, it would be at 4. 4. This one's from the right. From the left, we're on this side. And notice the graph is here at -4. So the limit from the left is -4, and the limit from the right is +4. Since those two are not equal, if we had to find the limit as x approaches 1, it would not exist.